Okay, this session is on distance and midpoints. Two distance formulas. If we just have a straight line, or like on a number line, then the distance between the 2 points on the number line is the absolute value of their difference. So we take the difference of the two numbers, a and b. You can say a minus b or b minus a. It doesn't matter. You just subtract them. But you take the absolute value of that, which means the positive value. Remember, distance can never be negative. You can't walk a negative 2 feet or drive a negative 10 miles. So it has to be positive. So just subtract the two numbers and make your answer positive, and that'll be the distance between those 2 points. For example, if we say that A is at number 2 and B is at number 6 on the number line, then the distance is going to be 6 minus 2, which is 4. Because it's positive, we just leave it. Another example, we can plug in negative number here, -5, -1. We subtract them. Remember, when you have two negatives side by side, you're subtracting a negative, it becomes positive. These are your algebra rules you have to remember. So -1 and +5, again, is +4. So you get the same answer either way. If you are on a coordinate grid, like so, then our formula for distance, D stands for distance, is the square root of our x values being subtracted, then we square that, the y values being subtracted, you square that, and then you add those two numbers together. Make sure you take the square root of it when it's all said and done. Okay, so in our example here, if we call this point, let me get a, we'll call this point 1. So this is my x1 and my y1 value. So it's going to be at 2, 3. And this is point 2. It's at -2, 1. Then we're going to plug those into our formula. So my my x1 value is 2. That's where this 2 comes from here. Then I subtract, just like the formula says. I just go straight through the formula. And then I subtract my other x value, -2. So that's where the -2 came from. Then I have to go back to the same point that I started with in the first set of parentheses. Put its y value 3 here. Subtract the y value of my other point, 1. Now remember, we want to do the parentheses first. Again, if I have two negatives right here, two negatives, then I get a positive. So 2 plus 2 is 4. 3 minus 1 is 2. Don't forget the squares on both of those. And it's still all under the square root sign. Don't forget to continue that square root sign all the way down. 4 squared is the same as 4 times itself, 16. 2 squared is 2 times itself, which is 4. Bring down the plus sign, and again, it's still all under the square root. 16 plus 4 is 20. And for now, we can just leave that as the square root of 20. We won't worry about simplifying that at all. Okay, so you're literally just plugging it straight in and doing the math. Now, where did the formula come from? How did we get that big old long formula? Square root of x2 minus x1 squared, blah, 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 blah. Well, it comes from the Pythagorean theorem. I'll do that yet. A squared plus b squared equals c squared. If we connect those two dots with our distance between them, and then we make a right triangle out of that, and it doesn't matter, we could have gone up and over this way, wouldn't matter, our lengths would still be the same. We call one side A, one side B. Doesn't matter which one, as long as C is the hypotenuse. And we plug those values in. So A has a distance of 1, 2, 3, 4. And B has a distance of 1, 2. We plug those in. Then we get this equation. A was 4, B was 2. We plug it in. Now, let's do the math. What was 4 squared? 16. 2 squared? 4. We still don't know what our distance between the 2 points is, that straight line. Shortest distance between 2 points is a straight line. What is 16 plus 4? 20. But that equals c squared. We don't want c squared, we just want c. So then we need to take the square root of both sides and get the square root of 20. So we get the same answer. So if you don't like memorizing formulas, then just draw a right triangle and count the lengths of your side A and your side B. Plug it into Pythagorean's theorem. It works either way. This way you need graph paper, coordinate grid. Okay. Sometimes we need to know what's in the middle, the point that's in the middle of a line or a line segment. How do we figure that out? Well, it would be the point that is halfway between your two endpoints. Halfway. Kind of like an average. So the midpoint M of our line segment down below, if I can get all the points to come up. Midpoint M of PQ is the point that is between P and Q, but it's right smack dab in the middle, so that the distance from P to M is equal to the distance from M to Q. So if the distances are equal, then we could put congruency marks here. And remember, when things are congruent, we can set them equal to each other. If we know that this is a midpoint, then we know that these two segments are congruent. So if this one's 4, then this one has to be 4. If this one's X, this one has to be X. If this one's X and this one's 2, then X equals 2. If this is X plus 2 and this is 6, then X plus 2 is going to equal 6. I can put anything in here and set them equal to each other. Okay? But how do we figure out where the midpoint is in a line segment? We have another formula. On a number line, the coordinate of the midpoint of a segment who have the endpoint coordinates A and B, you're just averaging. You're going to add them up and divide by 2. Because there's two numbers, you add up the endpoints and divide by 2. Okay, and I could put any numbers in here. So let's say A is -2 and B is 8. Then where is M? Well, I'm going to add these two together and divide by 2. I get 6 divided by 2, which is 3. So M is 3. Okay. So again, we're just averaging. If we're on a coordinate grid, you're just going to average your x's and average your y's. So add the two x's, divide by 2, because that's what averaging is when you have two numbers. Same thing with our y's. Okay, so again, we're averaging. So here's an example. what is the midpoint of point A, which is at 2, 6, and B, which is at -3, 5? Well, first of all, you need to identify your x and y values. So this is x, we can call it 1. So this has to be y1. This would be x2, and this has to be y2. So now we plug it in. Here's my first x, here's my second x. I'm going to add it and divide by 2. Here's my first y, here's my second y. I'm going to add them and divide by 2. So now what do we get? 2 plus a -3 is -1. Still have the 2 on the bottom. And 6 plus 5 is 11. Still have the 2 on the bottom. If it doesn't come out even, you can leave it as a fraction. That's perfectly acceptable. So don't worry about finding decimals. You can find decimals if you want, but it's less work to just leave it as a fraction. Okay. Why do we need to know about midpoints? Well, because sometimes we cut things in half. We need to know where that halfway point is. Any segment, line, or plane that intersects a segment at its midpoint is called a segment bisector. You need to know this word, bisector. We're going to talk about perpendicular bisectors and angle bisectors. A bisector is simply something that cuts something else in half. So you need to know right here that that means in half. Okay, always. So this line L is bisecting line AC, and this plane M is bisecting AC. They're both segment bisectors, cutting it in half. Okay. And sometimes we need to construct segment bisectors. To do that, we'll go to our mathopenref.com, and it'll show us how to construct it. Remember, constructions are done with just a pencil, a compass, and a straight edge on a piece of paper. So here is our line segment, PQ. We want to bisect it, cut it in half. So we place the compass point at one end. We adjust the compass so that it's over half the length of the line segment. So we got to stretch it out a bit. Again, be careful that the compass doesn't move. We draw an arc on each side of the line, not across the line, but on either side. So we're going to go up and draw one. We're going to go down and draw one. Then we're going to do that on the other side, but we have to leave the compass exactly the way it is. We can't change the width of the compass. We have to leave it the same distance. And we swoop again, up on top and on bottom. Then, if we draw a line between those two intersecting points, then we just cut line PQ in half. Notice the congruency marks. So that PJ is congruent to JQ. And there you have it. Okay, so know your new terms, segment bisectors, know your formulas for distance and midpoint so that you can use those to find different values.